Example 6.4, figure 6.7 shows planar loops of different shapes moving out of or into a region of magnetic field, which is directed normal to the plane of the loop away from the reader. Determine the direction of induced current in each loop using Lenz's law. Okay. First, we will see what type of magnetic field is applied. Here you can see the cross mark, that is into. Into means magnetic field is perpendicular but it is inward. Now, we will see one by one. The loop 1. Loop 1 is coming inside. Here mainly we are using right hand thumb rule. That is, suppose the magnetic field is inward, you have to take it to your right hand, thumb will be inward. The direction of current will be in the clockwise direction, right? Okay, that we will see now. First, we will go to first diagram. Here, the coil is coming inside. Initially, coil was outside. Field lines passing through the coil was less. Now, when a coil is coming inside, magnetic field lines passing through the coil increases. So, magnetic flux into the page is increases. Magnetic field increases means we can say magnetic flux linked with the coil increases. But now here given magnetic field is into. Step number 1. Let us take it to your right hand. Apply the right hand thumb rule. Magnetic field is inward. So your thumb goes inside. What's the direction of current? Current will be in the clockwise. But current is clockwise, but what happens here? When a coil comes inside, magnetic field increases. According to Lenz's law, it opposes the change. So clockwise, you have to change it to anti-clockwise. Why we have to change it to anti-clockwise? Because field lines increases. So answer is anti-clockwise. Now we'll go for the second one. Carefully, if you observe, second and third both are having same answer because both are taken out. It is going away from the magnetic field lines. Means number of field lines passing through the coil increases or decreases. Going away. Away matlab decreases, right? So in the second case as well as in the third case, both are going outside. So field line decreases. Step number 1. Take out your right hand and apply the right hand thumb rule. Thumb is inward. The curled finger is showing the direction of clockwise. Okay, now answer is clockwise. Why? Previous case we have changed. Here nothing to do because it is decreases. Decreases hoto already we got the answer clockwise. You have to keep it as it is. I repeat, whenever answer is increases, what is increases? Magnetic field lines increases. Step number 1, you are applying right hand thumb rule. Whatever the direction you are getting, you have to reverse it. Second case, if the coils are going outside, that is, if the field lines are decreasing, then you are applying the right hand thumb rule. Whatever the direction you are getting, you have to keep it as it is.